All right, trapezoidal approximations, 3 subintervals. Now, the problem with this problem, what do we observe f of x is doing somewhere along that curve? It doesn't necessarily change directions. It dips below the x-axis is my concern. So what tends to happen for this problem is students want to cut it into slices, but where will they want to cut one of the slices? Where would they want to break it? Why at 4? Oh, I get what you're saying. Okay, so that's one issue. Since the integral is from 2 to 8 and we're cutting it into 3 subintervals, you might want to cut it into equal subintervals, but it's not. That's the first issue. But if you look at the graph of the function f, it's up here. It goes up, it goes down, and then it goes back, and then it goes down below the x-axis, right? Yes. So when we go to look at that, do we know where it actually crosses the x-axis? No. But we do know it crosses the x-axis where? About? Between 5 and negative. Well, between 6 and 8. Yeah. Okay. We do know it crosses somewhere in there. So we make an assumption, or some of us try to make an assumption, that it must cross somewhere right in the middle or something like that. But when you go to slice it into trapezoids, you might be tempted to make a trapezoid and stop it at that x-intercept, right? We don't want to do that, okay? So we want 3 subintervals. What's the area of a trapezoid, first of all? B1 plus B2 times height, okay? So then the integral using a trapezoidal approximation will be 1/2 of what's base 1? Wait a minute, what's base 1? 8. Because that is the height, or that is the f value, the first f value, right? What's the second base? 12. And what is the height? How do we get the height? It's the interval from, or it's how wide the interval is, right? So in this case from 2 to 3, so 1. Plus 1/2 of, what's base 1 of the second trapezoid? 12. What's base 2? And what is the height? 3, because how far is it from 3 to 6? It's 3. And then plus 1/2 of 5 plus negative 3 times 2. Okay? So students might get caught up with the idea that that's positive and that's a negative. It's okay for the trapezoidal rule. Okay? You don't want to break it into another trapezoid so that the second base is 0 and the first base on the other one's 0. You don't want to do that. So did you guys evaluate that? So what do we get? 10 here? Plus 51 over 2? Plus 2? So let's see, that's 24 over 2 plus 51 over 2, 75 over 2? Are we good with that? Any questions on that one? Pretty straightforward? I think so. You guys are quiet today. No, I'm not going to guarantee that every problem will have different intervals, but I can't guarantee any of it. Sometimes it will and sometimes it won't. So since the intervals are different, could I have factored anything out of this? No. Well, the 1/2, that's it, right? But I did make a point yesterday that on a trapezoidal approximation, how many times are you using each base? Twice, except for the first one and the last one, but we use the 12 twice, the 5 twice, and then if we had multiple other ones. All right, we want the integral from 2 to 5 of x minus 1 dx. What do I do? So antiderivative would have been 1/2 x squared minus x. Evaluated from 2 to 5. So that would be 1/2 of 5 squared minus 5 minus 1/2 of 2 squared minus 2. So that is 25 over 2 minus 5, and this is just 0, I think, right? Okay, so what? 25 over 2 minus 10 over 2? So 15 over 2.